All right, folks. So now that we have figured out all of our internal forces through the moments step, and then through the sum of forces in the y direction and sum of forces in the x direction equals 0 step, we're now ready to start on our method of joints. In order to understand method of joints, you have to understand compression and tension. So you've got to make sure that you are looking at the link down below this video and go to the other video that's linked in there that talks about tension and compression, and make sure that you understand that before watching this video. All right. Assuming that you understand about tension and compression, you've got to understand why we need to understand what step we're on. So if we have a truss and we've got some forces acting on that truss. So let's say we've got a pin here and we've got a force going this way and a force going that way. Okay. And we've got a roller over here. In the moments part, let's see if I can make that a little better. There we go. So in the moments part, we have things trying to spin around the pin, right? They're trying to go that way. This one's trying to go that way, and this one's reacting in whatever way. We don't care which way the directions go. That arrow goes downward, which is just happens to be negative, which is also right-hand rule, negative moment. But this one, even though it's going negative x, is going in a positive moment. Okay, so moments is its own step. Once we're done with moments, we don't care about rotation anymore. Now we're looking at which direction the arrows go in the x or y direction. Left is negative x, right is positive x, down is negative y, up is positive y. So each step is its own entity. Now we're working on members, okay, internal structure. And it is really important to understand that, let's say that this member right here, we have A, B, C, D. So member CD. If we find out that CD is in compression, remember from the previous video, compression means it's being pushed on inward and it is pushing back. So it is pushing at D on one end, okay? But it is also pushing at C on the other end, okay? So now arrows go two directions instead of just one. So you have to understand which step you're in to be able to solve the truss. We are now going into the method of joint step. So here we go. Let's talk about how to do this. All right. And this assumes that you've done everything correctly up to this point with your other calculations that I've gone over in other videos. All right. So let's talk about how we're going to solve for method of joints. Now we're going to go to here and make sure we read. Draw one joint at a time, starting with the most simple joint to solve, which is usually the fewest number of forces. You really can solve any of them, but if you have more than three total forces, including members and forces, it's going to be more difficult. So here we could solve here pretty easily, because this force will be opposite of that force and this force will be opposite of that force, but that actually doesn't help us with future more difficult trusses. So we're going to try and we're going to start with this guy right here on this joint. My example, I'll come back to this one. Oops, that's the third one. The second one is my example. I think it's probably easiest to start with A. Everything else is quite a bit more complicated, so we'll start here. And on the last one, you could either start here or start over here. We'll probably start here. Okay, so here's how this works. Okay, we're going to draw, we'll start again with the second one. And we're going to start with joint A because that's what works out. Okay. All right. Now, when drawing a joint, you're going to only draw what's touching that joint. You are not going to worry about anything else. So for joint A, we have this. Okay, here's joint A. We have a 95-pound force pushing upward. We found that out earlier. We have a 30.96 degree angle. Now, again, your numbers are going to be different for your joint, right? Your force is different. Your angle might be different. Okay. Now, we're not going to draw anything else because these are the only things that are acting on this joint. Now, I do label which member this is just so I know, but I don't draw point C because remember, point C is not touching joint A. It's only what's touching this. That's AC and this is AB. Okay. Now, somewhere on here, we need to now list the forces on the joint in the X and Y direction. This is really, really important that you do this step. So we'll do this down here. What are my forces in the X direction and what are my forces in the Y direction? Now, this helps you to do a little puzzle that helps you figure out whether AC or AB is in tension or compression. Okay, here's how. So the forces that I have, this 95-pound is only in the Y direction. The forces that I have in the X direction are AB. AB is in the X direction, and we have AC in the X direction. AC, because it's angled, goes in both the X and the Y direction. Okay. On the Y side, we have a 95 force going upward, and we have AC in the Y direction. All right. So here's how this works. Okay. Now, later on, it's going to get a little more complicated if we have more than two forces in each direction, and we'll get to that. But if you do only have two forces or less than two forces in some cases, you can figure out which way the forces go on these other members, okay? If this one's going up, you know that the other one has to be opposite because it's static, right? It's got to be opposite and equal. So we know ACY is going down. That means AC is pushing downward. And if it's pushing downward, we also know that it's going to the left, right? Remember, since it's going down and left. So that means on the X, AC is going left. And if AC is going, X is going left, then that means that AB has to be going right. Okay? So this is how you solve for this when you have only one known. Is the other one has to be opposite. And if you have an angled member, then you know if it's going a certain direction, it's also going another direction, down and left in this case. And that means that the opposite of this guy has to be going right. So we now have found out that A is being pushed on by AC, which means that AC is in tension. Okay. And we know that AB is going to the right, which means that it is pulling on A, which means that it is in, oops, I put tension up there. Sorry, I messed that up. I don't know what I just said, but AC is pushing on A. That means it's in compression. Sorry if I got confusing there. AB is pulling and AB is in tension. Okay. Now we found out what directions it's going. Now we need to know, okay, how much? And this is where we start with using SOHCAHTOA in order to solve the problem. Okay. So now is when we're going to draw the components. Remember when we were doing force vectors and we can say, okay, here's a Here's a resultant force that we can move around. So our triangle, if we take that y force over here and move it over here, right? That's our component of that, okay? Now we have 30.96 degrees, and you can use your trig to solve for either A, B, or A, C, okay? I think I'll solve for AC first just because I feel like it, which means that I've got the opposite and the hypotenuse. So I'm going to use sine function because I've got opposite and hypotenuse. So my sine of 30.96 equals opposite over hypotenuse. Do a little calculating, and we will figure this out, okay? That means that AC equals 95. If we rearrange the equation, AC equals 95 divided by the sine of 30.96. Okay, so 95 divided by sine 30.96 in my parentheses, enter 184.67. All right, AC equals 184.67. Now, we're not dealing with positives and negatives because we are in the last step. We're in the method of joints, steps. So we now have 184.67, but we found out that AC was in compression. So your members are going to be showing either tension or compression, not a direction, because it's two directions at the same time, right? So 184.67, and it is in compression. I usually write COMP. Went outside the box a little. All right. Now that we know what this is and this is, it's up to you. You want to use Pythagorean theorem, do that. You want to use trigonometry, do that. I personally like trig. So I now have my I can use my opposite and my adjacent. So opposite and adjacent. So that means that my tangent of the angle equals opposite over adjacent. Same idea. Okay, multiply each side by AB, divide each side by tangent, and we'll get AB equals 95 divided by the tangent of 30.96. So 95 divided by, in parentheses, tangent of 30.96 in parentheses is 158.36. 158.36, and we found out that it is in tension. So AB is 158.36 in tension. Cool. All right. So now that we've done that one joint here, let's do the joints for the other two. So we'll keep on going one step at a time with each one of these. All right, let's talk about your second one. So originally I'd said that we were going to do joint C first, but that was mainly to show you how the trig works here. I think what we'll do is I'll change my mind and go down here to joint A. So we've determined that our external forces at joint A, RFAY and RFAX, were respectively 100 to the left and 57.14 down. So when we draw joint A, we know that we've got, this is AB and this is AC, and we know that we've got a 57.14 force going that way, and we've got 100 force going this way. Okay, because we found that out earlier. So it's pretty easy to figure this out. We've got forces in the X direction and forces in the Y direction. So we know we've got a 57.14 going that way. So that means that the other Y, which is AB, must be going that way. And we know that we have a 100X going that way, which means that our AC must be going that way. Okay, opposite and equal, right? So we know that we've got that. Therefore, when you're talking about that the sum of all the forces in the X direction equals 0 and the sum of all the forces in the Y direction equals 0, easy to figure out, okay? AC is going to be opposite of that. AB is going to be opposite of that. So, so that means that my AC for the X is going to be is 100, and it is going to the right. It means that it's pulling, right? So if it's going to the right, it's pulling, which means my AC is in tension, right? My AB is going upward with a force of 57.14. You could do negative 57.14 plus AC equals 0, but I hope you can see what's happening here. So AB is 57.14, and it is AB is pulling on the joint, so it is also in tension. All right, so let's update things. There's erasure marks because I made mistakes before. But so we know that AB is 57.14, and it is in tension. Okay, and we've got a 100, which is AC, which is also in tension. Now, we could go all three in a row, but since we're so close here, let's go ahead and solve this truss before we move on, because it's pretty easy to do. So now we've got joint B to deal with, and joint B has this and this and that going on. This is BC, this is AB, and this is 100 unit force here. Remember that we can move things, right? So we really have a triangle that looks like this, because we can take this force and slide it down here and say that this is 100. And we already found out that AB was 57.14. Okay. Doesn't matter directions because we're finding out a total amount of force. So A squared plus B squared equals C squared. Okay. You don't have to use trig. You could use trig if you wanted to, but so using Pythagorean theorem, it's the square root of 100 squared plus 57.14 squared. And we will end up with 115. So BC equals that. BC equals 115.14 point, I don't remember. I'm going to look at that. 0.18. And remember, we're going to find out. Oh, I didn't do my list. Let's do my list, okay, to figure this out. So I've got my forces in the X and my forces in the Y. Should have done that first to figure out whether it's in tension or compression. In the X, I've got 100 going that way, and I've got BC in the X direction. In my Y direction, I've got A, B, and I've got B, C, Y. Okay, so we knew this was going that way. We then know BCX is going to the left, which means that it's going up and left. Okay, and AB was going down. Is that true? Is AB in tension? Yep, so it's pulling on both ends. So we were right about that. And we know that our BCX and BCY is pushing, so it is in compression. And congratulations, you just finished a truss. BC is 115.18 in compression. And by the way, something has to be in compression and something has to be in tension. If you end up finding out that all three are in tension, doesn't work. Something's got to be in compression and something's got to be in tension. All right, cool. Let's look at now our last one for one of the joints on this last one. And we'll take a look at this guy, and I think we will start by this joint, and you'll understand why in just a moment. First of all, it has the fewest number of forces. It only has 3 things. Well, this only has 3 things, but we don't know enough about it. So here's why this is going to be really easy to start with joint C. Joint C has 3 things touching it. It's got CD, and it's got AC over here, and it's got a 150 unit force going that way. Now, forces in the X direction, forces in the Y direction. Forces in the X direction, there's only one, AC. Okay. Forces in the Y direction, there's 150 going down and 100, and so that means that CD is going up. Okay, so CD is going up. Now AC, there's no other force. So if we talk about the sum of all the forces in the X direction equals 0, and AC plus nothing equals 0, then AC equals 0. Okay, so AC has no force. Okay, it's neither in compression nor tension. If you think about it, it makes sense, right? Well, let's just pretend this is like some sort of sign thing that's hanging this sign from here. It's only pulling down, right? This doesn't really do anything. So it's got 0 force on it. All right, so we've determined the AC has 0. Now, we have determined that CD is sum of all forces in the Y direction equals 0. Okay, now we can do the math. This plus this, okay, equals 0, but we know that 150 is going negative, so the other one, CD, must be 150 going positive. Okay, so it's pulling on the joint, and if it's pulling on the joint, it is in tension. All right, so our CD, is 150 in tension because it's pulling. All right, now that we know that, I think where we'll go next is we'll go up here to B, because B is also fairly easy to find out. Okay, B only has forces in the X and Y direction, has no slanty things. Okay, and we got 150 going this way. I'm looking at this. We've got 350 going that way. Okay, now let's make this kind of a duh here, right? Here's A or BD. Oops, that's a D. BD. And this is AB. Look at it. It's a duh, right? BD is 350 going to the right. AB is 150 going down, right? So I'm even going to let you figure this with your numbers, of course, that BD is 150. Whoops, I'm looking at the wrong one. BD is opposite of this value, going in the opposite direction, which means that it is pulling on the joint and it's in tension. AB is 150 and it's pulling on the joint and it is in tension. A lot of tension going on in this. So we found out that AB, let's move that over a little bit, found out that AB is 150 in tension, and we found out that BD is 150 in tension. All right. Now, we will get to the last one on this one and the last one on your second one in the final step. All right. Good luck. See you in the final one.